Amino alien. There he is. We're going to make him mean. How about that? A mean alien. Make him grumpy. This is where it's most powerful. NH4. This is used in hospitals, nursing students. Here you go. When you needed to see the ammonia in the NH4 plus, remember that weird looking way they'd write it? That was just ammonia in an acidic solution. And acidic just means a proton. So here it is, the alien. And it's actually a covalent bond. It's not the hydrogen here where it's held by a different force. This is a real bond, the way I understand it. So instead of N, this is like the equivalent of a methyl in a way. It's nitrogen. So NH4 with a plus. So the electromagnetic force isn't near enough to hold that in a basic solution. So it'll go back to ammonia, NH3. So see the way we took that? 3 bonds. The books never draw electron pairs anyway. The electron pair is what makes ammonia what it is. Without that electron pair, it's not reacting on nothing. It's giving a real negative charge out there. So here, when you introduce some protons, they're going to suck up right there. Now here's another one, the phosphate. This is powerful stuff. Phosphoric acid. Drawing it with just letters is archaic, and that's being polite. So phosphoric acid has 3 OH groups. They're the equivalent of an alcohol. I hope you recognize that. Alcohol with an oxygen here, though, makes it an acid because it'll give those protons up. The most that you'll ever find is triprotic, they'll call it. Tri is 3. So phosphate with 5 bonds, it's going to have 3 oxygens bound to it that'll give up protons. So if you got 2 bonds left on a phosphorus, and an oxygen likes to have 2 bonds, because remember, one of those bonds on oxygen is going to a proton, one to the phosphorus. So there's 2 bonds on each of those. But up here, a double bond, like the ketone on the carbons, right? A double bond to an oxygen still has 2 lone pairs of electrons on it. So what will happen when you introduce this into an aqueous solution? This will stay the way it is. This over here will start giving up protons. And it's a neat introductory chemistry lab exercise to find these pH points, because there's 3 of them. Then you use the calculus, take the derivative, and find out where the next ones are, and you do concentrations. It's great, and they should be doing that in high school. That's one of the best introductory lab exercises there is. So you get the H2 PO4 minus, HPO4 2 minus, or the PO4 3 minus. That's the phosphate ion. Hydrogen phosphate. Technically, you'd have to call that dihydrogen phosphate. But they all have common names, so you hear just phosphoric acid. There it is, 2-headed alien. Now watch what we do on the other one. When this gets a negative charge, it turns into a 3-headed alien. So this is going to be powerful stuff coming up. We're still working on that. The other night, this is what got me. HUNTS tomato sauce, okay? I was going to make some spaghetti. I found this can. I was going to add it to a jar of some ragu kind, a little paste. Oh, there was another can. I think the big HUNTS can would meet one of those. I was going to make 2 servings out of it. So I was going to add just HUNTS tomato sauce. I looked at the sodium. There's one thing I always look at. 410 milligrams, okay? No biggie. Whoop, there we go. Yeah, we've done that before. What did we say on that again? 400 90 milligrams. You're not going to be able to read that. So 490 milli. Just, this is cool. Don't be afraid of the units. This is grams, but this is a milli. Believe me, intro kids, I know M is used for meters and all these other things, and they don't tell you that, do they? It's the same small case M. This is milli, 10 to the minus third, think of it, okay? Which is 0.12 with a 1. So we're talking milli, less than 1. Technically, be a decimal point there. 0. Okay, so almost a half a gram is what that turns out to be. So for common folks, we'll do this, a half a gram of sodium now, okay? Sodium is technically the ion of what? NaCl. Cl is a lot bigger, okay? Check this out. If there's a half a gram of sodium in this can, you would have to multiply it by the number of servings, number of 7. This will feed 7 servings. This little can of 15 ounces, they call a serving 2.12 roughly, I think. 2.12 ounces is 1 serving, according to this. A quarter cup, they call it. Should be 2 ounces, wouldn't it? Quarter cup. So 2 times 7, yeah. 2 ounces, roughly. They're calling 2.12, I figured. Check it out. Times 7. Put that other kind of marker down there. What's 1/2 times 7, kids? I know you hate math, but you got to be able to at least do this in your head. 1/2 times 7. 3.5. 3.5, because this decimal point, this is where you guys got to learn this, because they're not pencil whipping you. We used to say labels don't lie, but liars label. 3.5 grams of sodium, just flat out, is in this can. I hate to keep showing Hunts, but this is the highest. So sorry, Hunts, you're getting your name out there. The Hunt brothers selling silver back when see, they're making money. I sold all those silver coins my Aunt Grace gave me when the Hunt brothers cornered the silver market back then. So look at the point here. When the doctor tells you not to put salt on your food, well, look, 0.490 milligrams per serving times 7. We're going to write that in decimal point here, because look, kids, I want you to have to learn a little science here. 3.5 grams of sodium in 1 cup. What we're going to look at is 1 gram of sodium is going to equal how many grams of chlorine to make sodium chloride. I'm going to show you the equivalent of how much salt you would have to put on your hamburger compared to what's hidden in a can. You're going to see here. I got to get a bigger screen. Here we go. Here was an old topic we did. This was pretty cool. Carbonic acid, carbonate. We were just showing the phosphate before, remember? So picture instead of the carbon here, there being a phosphate. Oh, this is a great topic. I hate to waste that board. Tell you what, we're going to use the Sea Star Memorial board. How about that? All right. Somebody stole our eraser, but the amino alien's gone here. This is a real chemistry equation here, kids. This is what's called your given quantity. 3.5 grams sodium ion. Now what we have to do is convert that to moles.